For the next 2 days, our theme is going to be what is the denominator. To graph tangent and cotangent, there are multiple methods. The method we use, and for secant and cosecant, is to focus on the denominator, and the denominator will lead you to the graph of tangent and cotangent. With that being said, if we're talking denominator, we're talking fractions, right? And so when we talk fractions, there is a time that a fraction is undefined. Agreed? And what is it about a fraction that makes it undefined? Actually, what number in a fraction is a 0 in the bottom, right? So a 0 in the bottom is when a fraction would be considered undefined. What did that look like in our graph? Well, first semester, we graphed fractions all the time. We had an entire chapter where we graphed something like this, and we were drawing in our horizontal asymptotes and our vertical asymptotes and our x-intercepts and our y-intercepts and all that to get this beautiful picture. But what was it we drew when we set the denominator equal to 0? And I found out that x equals 3. What then I then go draw in my picture? A vertical asymptote, right? So what does it look like in a graph when something is undefined? It looks like a vertical asymptote. Tangent and cotangent at certain points along our unit circle are undefined. We will now see today these things that we weren't seeing before, vertical asymptotes. What does 0 look like on a graph? Remember that that's a name we use for when our graph hits the x-axis, right? It's just, we call this many things, solutions, x-intercept, or a 0 of our function. So when it hits the x-axis, the function's value is 0. Kind of combining those ideas today, and thinking about fractions and when they are 0 and when they are undefined is what builds our tangent and cotangent graphs. So what we're going to do is think of tangent and cotangent as fractions in terms of sines and cosines. We already know this from thinking through our unit circle values that tangent is your sine value over your cosine value, right? So of those two numbers, what will tangent equal if I tell you that my board died. There we go. If I tell you that tangent is, or tell you that cosine is 0. If I told you cosine had a value 0, what would you tell me tangent was? Undefined, right? Because it would end up being something like that. Okay, well, where does that happen? It happens when cosine is 0. Cosine is 0 here. Cosine is 0 here, so that's going to happen at pi over 2. That's going to happen at 3 pi over 2. What is tangent if sine is 0? 0, right? And sine is 0 here and here, which would be at like 0, pi, 2 pi, however you want to count those. So depending on where the 0 falls in the function, our tangent will either be undefined or 0. And it's those two concepts that we're going to bring in to graph our tangent curve. On this page, when I talk about graphing our tangent curve, I'm going to put great directions on here. I'm not going to do that for cotangent because they're pretty much the same with the tiny little changes in it. So take good notes on this page so that you have it later for cotangent. When we are graphing tangent and cotangent, I want you to consider what it is as a fraction, sine over cosine. And we will always focus on the denominator. So job number 1 when we are graphing this is we are just going to go over to our graph and we are going to dot the denominator. So dot out a cosine curve. And I picked cosine again because it is the denominator. I'm not going to actually draw a cosine curve. I'm just going to put the dots like I'm starting to draw a cosine curve. So the dots I would put out here to draw a cosine curve would be here, 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 right? We're hopefully getting really good at that part of it. Now, we just talked about a couple of pages ago that every single place that our graph hits the x-axis, our function has a value of 0. So at each of these dots, cosine equals 0. And so at each of those dots, we would put a 0 down here, which would make our tangent undefined. So that's going to explain then the next step in this, and that is at each of the dots on our midline, we're going to draw in a vertical asymptote. Every dot that is on our midline, we are going to draw a vertical asymptote. And as always, please word this in whatever makes sense to you. So I'm going to come over here, my cosine curve hit the x-axis here, or hit my midline, I should say, here, hit my midline here. Every place that it hit my midline, I'm going to draw in an asymptote. Okay. Now, the next part, I will never ever do this again after this example right here. But then, okay, so how do we then draw a tangent curve? We haven't drawn anything tangent yet. We've drawn in the asymptotes that kind of break it up. And I'm going to look at the numerator. The numerator is a sine curve, and our tangent will equal 0 anytime sine equals 0. So if I were to lightly dot out a sine curve, it would go here and here and here and here and here. Notice that every place right between our asymptotes, our sine curve, is hitting the x-axis or our midline. And every place that means sine is 0, which means tangent is also 0. So those dots that came from my sine curve are actually the dots that I will use to start my tangent curve. So the first dot that I draw for my tangent curve is on my midline, exactly halfway between my asymptotes, for the reason I just talked about. So put a dot on the midline, halfway between the asymptotes, which would be each of these dots right here. You will never have to draw or dot out the numerator, but I just use that to explain why. That's why tangent is 0 at those places. Okay. Now, the next dot that we're going to draw in our tangent curve, I'm going to explain to you so you're not, I'm just not like throwing some random dot out there. It really is a tangent value. If we were to go back to the markings, and I kind of like covered them all up, but like that's 2 pi, that's pi, this is pi over 2. With me on that? Okay. So between 0 and pi over 2 would be half of pi over 2 or pi over 4. Yeah? Okay. Now, big trip back to our unit circle, pi over 4 for my hand trick people here. Pi over 4 tangent value would be square root of 2 over square root of 2, or 1 isn't tangent 1. So does it make sense that I'm putting a dot here over pi over 4 up 1 because tangent is 1 at a angle of pi over 4? Okay, that's where that dot's coming from. It's the tangent value. So then moving the other direction, if I were to go to the left halfway, that would be a negative pi over 4. But negative pi over 4 puts us into quadrant 4. Tangent's negative in quadrant 4. So instead of going up to positive 1, we're going to go down to negative 1. Those 3 dots that you see right there are the requirement for your tangent curve. You have to have the one on your midline, and then you have to have the 2 that are off your midline to show the amplitude. So then to draw in, oops, let me write that here in our directions here. So the 2 other dots I did, and again, your words, whatever makes sense to you, I went right halfway, up 1, and then I went left halfway, because that's where pi over 4 is, and I know what tangent of pi over 4 is. So I was just kind of going to a place that, first of all, gives me a nice answer for tangent that I can graph, and I can find on my picture. And the last thing is to connect my dots. So when I connect the dots, your line is going to slide along your asymptotes, squiggle through your dots, slide along your asymptotes. A tangent curve will increase between the asymptotes. So write that for yourself however you want to. I'm going to really highlight the fact that it increases because that is one of the main differences between a tangent and a cotangent. Tangent curves increase between our asymptotes. Now, if we were to have an ROX, that would flip and it would decrease between our asymptotes, but a normal tangent curve will increase between our asymptotes. Now, requirements. You must fill between all asymptotes. It is the exact same pattern over and over. I have my first dot there, so then I go over halfway up 1, left halfway down 1, increase between my asymptotes. right halfway up 1, left halfway down 1, increase between my asymptotes. Now, I do have some people that it will bother them that it's not filled all the way to the outsides. You are welcome to draw a tangent curve out there as well. You'll notice on a lot of my answer keys, I draw from negative 2 pi to 2 pi, which wouldn't actually be quite a full curve out there. So I draw like, it's kind of a truncated, it's just this part of it and this part of it. You don't those are not required. You don't have to do the very outsides, but it does bother some people to leave those blank, so you can fill that in. The other thing that does bother some people, and I just want to make sure that we address this on the front end. Did you notice that after I dotted out the cosine curve, I never did anything with this dot that was off of my midline? Guys, they mean nothing to us after we get our asymptotes. The sole purpose of dotting out my cosine curve was to figure out where those asymptotes were. So this we don't use for anything at all. And if you want to go back and erase them, that's fine. If you leave them in there, beautiful. I don't care. Mine, I think, are always in there because I always dot out a cosine curve and then move on to my asymptotes. So, any questions on that? That's your basic, okay? Your book gives you all the properties, so if you want to go look at the properties, it kind of looks like in your notes and up here that I've highlighted these things as if they are something that we have to memorize. Guys, that is not something you have to memorize. The location of the x-intercepts, okay, well, the location of the x-intercepts are where the numerator equaled 0, which you don't need to remember, right? The location of the asymptotes was where our denominator equaled 0. You don't need to remember this fancy formula. If you can draw a cosine curve, you found your asymptotes, okay? Any questions on that? The other thing is this, and one of the things that is unique to tangent and cotangent is that it has a different period length than the other 4, sine, cosine, secant, cosecant. Because you hit every single value in only a length of pi instead of needing 2 pi to get all of that. Because every single one of our curves is the same between our asymptotes, and all the asymptotes are only pi apart. Will that impact you after today or even today? Not at all, okay? The way our method for graphing this kind of takes that out of it. You don't have to remember that ever. It's not going to impact what you do at all, but it is true, is that it only has a period length of pi instead of 2 pi. Okay, so then how do we graph transformations? Now that we have our parent function, how am I going to go about graphing a transformation of a tangent curve? All you are going to do is always keeping in mind your fraction, that you are going to just rewrite your equation, and instead of cosine, or instead of tangent, we're going to put in whatever the denominator is of that function. So I'm going to rewrite every equation, but plug in either sine or cosine, whichever is the denominator. So you would see me rewrite this as cosine of 2 pi x. I mean, not 2 pi, 2x. And now I just graph cosine of 2x, like I've been doing for the last week and a half, right? So that is no different. It has one transformation in it, a b value of 2. Okay, well, if it's a b value of 2, what's the period on this graph? Pi. I'm going to kind of hijack our numbering here. The way we always do that, I go to my 4th tick mark and I label it as the period pi. And I dot out a cosine curve because that's the denominator of tangent. That every place then that cosine curve hits my x-axis, which is our midline, because our midline has not moved, that we draw in an asymptote. So now once I've dotted out cosine, I move on to my tangent curve. I don't connect the dots. I take each of those places that hit my midline, and I draw in my asymptote, and then I follow my formula, or my little pattern for drawing in a tangent curve. So on my midline, first dot starts on your midline exactly halfway between my asymptotes. Then I go over right halfway, up 1, left halfway, down 1, and I increase between the asymptotes. And I fill in between any asymptote that's in my picture. Right halfway, up 1, left halfway, down 1, increase between my asymptotes. There are kind of some minimum requirements, just like we've had for all of our graphs. One of those minimum requirements is you literally have to draw in the asymptotes. They have to be there. The other one is you have to have 3 dots. Okay, so for each of these. Now, when it's not changing the amplitude, that is not really going to matter because people think it doesn't matter. But when I said up 1 here, that up 1 is actually going to be up the amplitude, which we're going to see one with a change in our amplitude. We pretty much have like one of each of our transformations today for our examples. So when you go up 1 and down 1, eventually when I change the amplitude, we'll go up whatever the amplitude is. All right. Let's try an example that has an ROX in it. Again, you're going to notice every single one of these. I will continue to remind myself what that is as a fraction in sines and cosines. I will always rewrite the equation and take out tangent and replace it with the denominator and just graph it as if it were a negative cosine of 1/2 x. No different. Apply all those transformations to the cosine like I would have. What is the period on this one? 4 pi, right? 2 pi divided by 1/2. Now, because of the dots that are off of my midline don't actually mean anything, if I were to forget the ROX, it's actually not going to change anything because my dots on the midline are still going to line up in the right place. So that's not as big of a deal. I'll always graph all transformations to my cosine curve just like I would the tangent. So, but if you were to not graph that ROX, I do want to point out it actually wouldn't change where our dots on the midline would be located. But I go dot out that cosine curve. I've applied all of these transformations, and so then I now have my dots out there. I shift to my tangent curve. Find all the dots on my midline, draw in my asymptote. But this time what's going to be different is the ROX, and so my graph is going to flip over the midline. So my dot on the midline is not going to change, but because of the ROX, it's going to decrease between my asymptotes instead of increase. So instead of going right halfway up 1, I go right halfway down 1. That one gets flipped below, left halfway up 1. And you'll notice this time my graph decreases between the asymptotes because of the ROX. And again, you are welcome to fill out all the way to the negative 4 pi and pi on the very ends if you want. You don't have to. You just got to fill between any asymptote that we have. Far right would go this direction. Is that what? Yeah. And this one would go like that. Yep. And if you drew an entire curve there, that's fine as well. It doesn't bother me if you draw one more full curve out there. Jordan?
How many different versions of the same graph can you have?
There aren't. There aren't. We have not seen a vertical shift and we have not seen a amplitude. So we just have to see those. And the only change also then too is looking, we haven't done a phase shift. We have 3 transformations that we haven't seen. Yeah, so we're just going to look at each of those transformations and how that changes. And bring in a cotangent curve. We haven't done a cotangent curve yet either. But getting the hang of it, right? Yep. Okay. Denominator is cosine. I rewrite it as cosine. The only transformation happening on this is that we have a phase shift. Ooh, which direction is this? Left. Pi over 2. No change on my numbering, so I'm going to come over here and number like normal. I'm I'm going to dot out my cosine curve, but I'm going to start at left pi over 2 of my usual. So my usual would be here at 1, 0, 0, 1. Move it left pi over 2. So I'm going to pause there. That's my starting dot. We all good with that? And then follow your pattern. So now I'm going to go back to my midline, below, midline, above. Fill in the other direction. I've dotted the cosine curve, so now I switch to tangent, which would be starting at each of those points that hit my midline. And draw in my asymptote. Now, here's just a little helpful hint of something that I see as a common mistake. This asymptote right here that runs along your y-axis, people tend to lose it. It like blends into your y-axis if you don't like use a different color or draw it off to the side or make sure that it's like super bolded in there so you know it's there. And what happens is they accidentally make this middle one like doubly wide because they forget that there's an asymptote there. Common mistake I see, so just kind of helping you down the road here. But again, other than that, our process does not change. So my dot starts on the midline, exactly halfway between my asymptotes. This one did not have an ROX, so it should be increasing. So we're going to go right halfway up 1, left halfway down 1, and we fill in that pattern all the way across our graph. Yes, if we were using tangent to graph this, but we're using cosine, right? So cosine's period is still 2 pi, with b being 1. Notice the length between our asymptotes are a length of pi. So remember, I used cosine to do all of the drawing on this, right? So we use cosine's properties to think through the numbering and everything. Yeah. Good with tangent, because we're moving on to cotangent. The only difference is this. Notice in our picture you see how cotangent's decreasing. Okay? What's not as obvious is the fact that our asymptotes are in a different place. But our asymptotes are now going to be based off of the denominator, which is now sine. But the exact same thing. We'll dot out a sine curve now instead of a cosine curve. But other than that, the only thing that's going to change. Okay, so why does this one decrease instead of increase? Remember that cotangent and tangent are just reciprocals of each other, right? Well, at pi over 4, which is here, tangent had a value of 1. What's the reciprocal of 1? 1, right? So it still is up here at positive 1. This point right here, halfway between pi over 2 and pi, is 3 pi over 4. 3 pi over 4 is in quadrant 2. Tangent is negative, which means cotangent is negative in quadrant 2. That's why it decreases between your asymptotes instead of increases. Not something we have to super remember. So giving ourselves an example of a perfect cotangent curve, because it is the fraction cosine over sine, we will dot out the denominator sine. So I put my sine curve out here like normal. Again, the dots off of our midline don't eventually mean anything to me. It's those dots on my midline that drive my graph now. Any place that our sine curve hits the x-axis makes it 0, which would make cotangent undefined. This cotangent's normal curve has an asymptote at the y-axis, which again, don't lose it. Don't let it blend into your y-axis there. Same type of process. Start on your midline exactly halfway between your asymptotes, but it's going to decrease, which means go left halfway up 1, right halfway down 1, decrease between your asymptotes. Okay, so we have 2 transformations left to see because we have not seen an amplitude and we have not seen a vertical shift. So we're going to use cotangent to help us see those last 2 types of transformations. We will start with one that has an amplitude. You're going to notice our process is very similar. I do need to remember what the denominator is, but I'm just going to rewrite the equation using the denominator. Okay, two transformations in this. We've got a phase shift. We've got an amplitude. Does that change the numbering on my x-axis, either of those? No. Okay, so we're out to 2 pi, negative 2 pi. We do have a change in our amplitude. I do need to see up to 3 and down to -3, so I'm going to number on there to make sure that I can do that. So however you want to number your y-axis, we need to be able to see all the way up to 3 and -3. I'm supposed to start which direction? Right, pi over 4. And pi over 4 is that ugly one, if you guys remember. It falls halfway between these two because this is pi over 2. Half of that would be pi over 4. That dot right there would be your first dot on this sine curve, which means every single one of our dots is going to fall exactly halfway between the tick marks because they're all shifted halfway. So I'm going to go halfway between the next two, up 3, back to my midline, go halfway between the next two, down 3, back to my midline, fill in the other direction, halfway between, down 3, back to my midline, up 3, back to my midline. The midline ones are really all we care about. Those are our asymptotes. So now I stop drawing sine and I start drawing cotangent. Drawing my asymptotes where it hits my midline. And follow your normal pattern, exactly halfway between and decreasing. But this time, as we go to draw our dots, this is why you have to have 3 dots every time you draw this, because when we have an amplitude, the only way to see an amplitude, because it's just like this random squiggly line thing there, right, is to actually show the dot. So I go over halfway to the left, up 3. That dot has to be visible. Right halfway, down 3, and again, the 3 because of the amplitude. It's stretching our graph vertically by 3. And I do that with all of them. Left halfway up 3, right halfway down 3, decrease between my asymptotes. Okay, there's your amplitude. Last one we need to see is a vertical shift, and I would say if there's any mistake that happens on a tangent or a cotangent, it's one of two things. Not putting the first dot on your midline, like putting it like at the top or bottom of your curve or something. And then when we have the vertical shift, is remembering that the vertical shift basically eliminates the x-axis. Everything is always focused on the vertical, wherever the midline is. The x-axis doesn't exist after we move our midline, right? So we've got a cotangent, we've got an ROX, we've got a change in our period, but we have the vertical shift, and that's why I want to do this one. We focus on our denominator. I'm going to graph negative sine of 3x minus 1. Okay, so we've got a couple things going on in here that we'll have to eventually remember. An ROX, we actually start here, right? B value of 3, what's the period if the B value is 3? 2/3, 2 pi over 3, right? That's the labeling on my 4th tick mark. And remember, that really is like 2/3, which means half of 2/3 is 1/3. You got it. We don't really have an amplitude, well, we have an amplitude of 1, but we do have a vertical shift. If you go back to like your trig summary sheet, remember we talked about the order in which we want to attack graphing these. Marking the x-axis, done. The second thing we always did was then draw in the midline. So our midline is supposed to be moved down 1. Move your midline down 1. Actually draw in a midline down here, and that becomes the center of our graph, right? And this x-axis basically doesn't matter anymore. Has no impact on our graph. It's all based off of our midline. So now I'm going to draw a sine curve with an ROX there. So my sine curve starts on my midline. Over 1, down 1 because of the ROX. The ROX is not actually going to change. I mean, make sure you get that when you get your cotangent curve going. Now I picked this one for a couple reasons. Sometimes we get confused with hitting the x-axis versus hitting the midline. It's the midline is where your asymptotes are. So yes, there are a couple dots on your x-axis, but it's the dots on your midline is where we have our asymptotes. So any place our sine curve hits the midline, we draw in our asymptote. Okay? And finally, if it's an ROX of a cotangent curve, our cotangent curve should be doing what between our asymptotes? Increasing. You got it. Okay? So we follow our normal pattern. Exactly halfway between our asymptotes on our midline. Over halfway up one, left halfway down one, so that it increases between the asymptotes because of the ROX. Remember that first dot is always on the midline. Yep. You'd be amazed. I look at 100 of these graphs a year for every problem you do. So get pretty good at reading them. Okay. All right. You guys have now your tangent and cotangent to add to your summary sheet. So flip over to the graph part of it. We're going to draw ourselves a perfect tangent and cotangent curve on there. You can get that from your notes. I will draw one up here in just a second, but those that feel comfortable putting that perfect tangent or cotangent, go ahead and add it to your trig summary sheet. There is one reminder on your worksheet that I will also flash up there, but you have on number 7 to remember to factor out a b value. You don't have double parentheses. We've practiced that before, and I told you we won't see it often. You see it again on number 7 on your worksheet today. If you are having trouble or worried about that you're not getting your graph perfect, I'm going to go ahead and graph it up here. If you are feeling good with yours, go ahead and move on to the worksheet. Tangent, we want to remember, I always remind myself what that fraction is, which is sine over cosine, which reminds me that I'm dotting out a cosine curve when I do this. Oops, that's not a cosine curve. The dots off of our midline don't mean anything to us as we draw this. It's just our dots that hit. Our midline that we start exactly halfway between, over to the right halfway up one, left halfway down one, increase between our asymptotes. A cotangent curve is cosine over sine, and again, we are focused for the next 2 days on the denominator. So I'm going to dot out a sine curve. So that I can find every place that it hits my midline is an asymptote for my cotangent curve. That our cotangent curve starts exactly halfway between our asymptotes on the midline and decreases. So left halfway up one, right halfway down one, decrease between my asymptotes. I will leave those up there for you, but I am going to flip to this last page just to show you again. Number 7, You have to factor out the B value or you will have the wrong phase shift. We've seen one like that. We've practiced factoring it out, but we get going so quickly that we kind of forget to look for the double parentheses. So on number 7, factor that out. And if you need your perfect graphs, here they are again.